Good morning, mathematicians. We're back to it. And I don't know what I want to do today. I was feeling inspired towards graph theory yesterday, and now I'm like, well, I kind of looked up the solution for what I was interested in. Maybe we could go back to it anyways, but yeah, I mean, what else are we going to do? Not look at graph theory? That doesn't seem like an option. Back to graph theory it is. Okay, so we were talking about graph theory and lattices. We were looking at Godsill and Royal's book, so let's go back to that. And yeah, how's everyone doing today? Hello, Leo. What graph? Why graph? Why gaff? Why gaff indeed? Why gaff indeed? Why no gaff? Have you asked yourself that question ever? Where were we here? Laplacian line graphs, root systems. But I think we're nearer the beginning too, so let's go 265. Well, you ain't arguing no gaff. What good you not ain't is. Don't be not ain't don't didn't. What brought about gaff? Everything brings about gaff. It's connected to all things. Don't you know? Hence a graph with minimal eigenvalue at least 2. Okay, where were we in all of this? I think we were looking at this example. You started reading some computational topology. I had no idea that was a thing. First time reading something beyond undergrad textbooks. Hell yeah. This is your awakening. It's happening now. And picking up recent papers. Nice. That's the way to do it. I've never heard of computational topology. Computational algebraic topology, maybe. So that's interesting. Okay, star closed sets of lines. This is we got to read about this. So let's see. Generalized gaffes. Generalized line gaffes. Weird, you don't see that message in chat? Wait, which message? I put on live chat. Oh, computational algebraic topology. Okay, that makes sense. Okay, so if we have a set of vectors in Rm of each having length squirt 2, such that their pairwise inner products are in -1, 0, 1, then the set of lines has a property that any two distinct lines are at 60 degrees or 90 degrees. Yeah. Lines at 60 or 90. And we're going to classify all such lines. I think it's time to email Kay. Maybe you'll do that now. Well, I heard that yesterday. How are you, Rod? I'm doing well. I can't speak for the rest of chat, but I'm doing well. Uh, YouTube chat is a confusing thing in general. There are two chats. Oh yeah, there's live chat and there's top chat. And fan funding. We got to do that soon. We're coming up. I feel like the velocity of my subs is like slowed down as we approach 10,000. It was going up. It's going up by a few a day, but hasn't gone up by all that much in the last couple of days. It's because I got to put out more interesting content, I guess. Got to be a slave to the algorithm. There's a normal chat and then the secret one for cool people. Yeah. So set is maximal if we can't add any new line at 60 or 90 degrees to those already given. All maximal sets are finite. To see this, consider the points formed by the intersection of lines with the unit sphere in Rn. Since the angle formed at the origin by any 2 points... Wait, what? All maximal sets are finite. Consider the points formed by the intersection of lines with the unit sphere in Rn. Since the angle formed at the origin by any 2 points is at least 60 degrees, the distance in Rn between any 2 points is at least 1. Since the unit sphere is finite area, this means we can only have finitely many points. Okay. Sure. I think I see what's going on. That is exactly my email, Leo. How did you know? But that's my super secret haughty big boy email. You could try the email that's in the link that's in the description of every one of my videos. I might be more likely to respond to that one. Okay, a star is a set of 3 coplanar lines with any 2 at an angle of 60 degrees. Okay. Should we draw a picture? Let us draw a picture in R2. In R2, that would be easy, right? Let's see. How do we draw this in R2? I mean, somehow dn should be one of these, right? But let's just start trying to do it. So let's see if we tried. Let's say we picked this vector. And then let's say we chose the vector that was at 60 degrees. Yeah, what could we do? So we've got, here's some choices. We've got like I think this is the dn one, right? Just the square root system. So all of these are at 90 degrees. So this would give us, what are we looking for? What's it called? Whatever, it's just a set of lines, I guess. Is it maximal? I think so. This is maximal, right? Because where are you going to put in another vector, right? If you tried to put one at 60 degrees here, it would be 30 degrees here. You couldn't do it. So this would be a maximal set of vectors. In a similar way, we might try to go around the circle, breaking it up in terms of 60s. So this would be, if we could start here and go 60, and then we could go here at 60, and then I guess the next one would be here, and then the next one would be, no, wait. Did I miscount? Oh yeah, that's right. That's right. And then the next one would be here. And I think these are really the only possibilities, right? I don't know if there's one. I don't think there's one that's a mix of 90s and 60s. Only through the origin? Are the lines here only through the origin? Oh, actually, that's an interesting question. Yes. Well, yeah. Yeah, because it's the line spanned by a vector, right? So. It's a line spanned by a vector. Yeah. So what does it mean to be star closed? A set of lines is star closed if for any star, if two of them are in the set of lines, then the third one is in there. Okay. You were late today? I mean, I started late as well, Locke. Yeah. Not gonna lie, you really had to think for a second for what 60 degrees is, yeah. Degrees? I haven't heard that name in years. I mean, everything's radians, right? Who even talks in degrees anymore? Let L be a set of lines at 60 and 90, and suppose that A and B are two lines at 60 degrees. And we can assume that A and B have length square root of 2. And choose B such that their inner product is 1. Wait, why can we do that? That's minus 1? Why can we do that? That's not clear to me. Then A plus B also has length 2? Okay. And the line spanned by A plus B is going to form a star there. Yeah. We show that A plus B is either an L or is at 60 degrees or 90 degrees. Oh, well, okay, I see. Right. We can choose it to be minus 1 because it's at 60. They're at 60. So this isn't going to be inner product 0. So it could be 1 or minus 1. I guess we choose minus 1 to just make some of the algebra work out. On pi versus tau? Ugh. Who cares, man? Your position has always been tau is clearly more natural, fundamental, but changing it doesn't make enough of a difference. Yes, yeah, I agree. That's the only take. What's the T? Boris, it's coffee. Come on, you should know this by now. Right, 1 versus minus 1 is about orientation, yeah. You're right, I am about orientation. Yeah. I think about this a lot with, like, language. Okay, there's a lot of different contexts in which we could think about this, but I think there's arguments for using certain kind of language or not using certain kind of language, like in a very broad sense. But the trouble with this is that it really sort of just evolves on its own, right? And so it's very hard to make a conscious decision to change the way that people use certain phrases, if that makes any sense. Maybe this is too abstract what I'm saying, but the reason to change would literally be to make trigonometry easier for high school students. Tau over 4 is easier to see a quarter circle than pi over 2. Yeah. That might be a good enough reason, I guess, but I guess. And yes, if given the choice, if I could wave a magic wand and go back in time, and so that life had worked out, that we had already introduced the Tao a long time ago, yes, I would make that choice. But now that we're here, I think it's difficult to choose. And to be perfectly honest, if that is an insurmountable barrier that becomes the difference between you grinding through your high school math class and not a factor of 1/2, then I feel like you're kind of cooked, to be honest. The categorification of pi? What the hell? Oh, I think we've talked about this before. Groupoid with cardinality pi. Still shocks me. Here in Europe, we do trig with Celsius. What kind of... I'm missing the joke here. Oh, degrees, radians. Okay. Hello, Kostaka Corey. If some John comes up with a natural categorification than Tao, then you'll believe it. Ooh, especially if it's more natural than the one for pi. Don't ask about Celsius, Leo. Stick to your freedom units. These fascists want to, turn you into a communist with their logical unit systems. Oh, they all, right, is communist propaganda. Oh, the conversion factor is the same for all units, for all changes in units. Oh, everything should be a 10. Oh, you think everyone should be the same? Dirty communist propaganda. Yeah. You think the factor of 1/2 makes a bigger difference for students at that level than people think? Maybe, but again, I don't know. If how many people are really at the border of... I don't know. It's a silly conversation, in my opinion. You're back. But you had to go for a bit right after you joined. Why are we discussing Tao? Good question. Let's stop. Let's discuss actual math. Oh yeah, because Leo doesn't know angles. Yes, that's the actual answer. Okay. We want to show that a plus b is either in L or is at 60 or 90 to every line in L. Right, because if it were maximal... I see. So let X be a vector spanning line of L, then the inner product is this, and so it's in these sets of things. If we're plus or minus 2, then X would have to be plus or minus this, and so therefore this would be an L. Otherwise it's at 60 or 90. Nice. And so it could be added to the larger set of lines. Nice. Yeah, that's true. I'm an elitist snob, and I'm trying to gatekeep the rest of math because there's already not enough jobs. So why am I giving out free knowledge? Why do I make videos giving out free knowledge? I really shouldn't be. I'm working against myself here. Why would a math book use degrees? This is a good question. What happened to radians? I don't know. That's what's wrong with this country. We note that the converse of theorem 12.2.1 is false. For example, the 4 vectors in D4 are pairwise orthogonal and therefore span a star closed set of lines at 60 and 90. Oh, but they're not all of D4. I see. We record a result which we'll need later. The proof is left as an exercise, which means we can skip it. We never have to think about it again. The set of lines spanned by the vectors of Dn is star closed. Yeah. Hi, Mom. Thanks. Have I wish a great day upon you as well. May a great day be upon you. Okay, reflections. We can characterize star-closed sets of lines at 60 degrees and 90 degrees in terms of their symmetries. If H is a vector in Rn, right. So we just got the formula for reflections in the hyperplane determined by a vector. A set of lines. Suppose we have a set of lines at 1690. Then L is star closed if and only if for every vector that spans a line in L, the reflection fixes L. Yeah. And a root system is a set of vectors in Rn such that if H is in S, then we only have H and minus H. Oh, that's an interesting way. I've never seen anyone write it in specifically that way. Of course, root system is like the same definition no matter where you look. I've just never seen this particular compact way of writing it. Which in PGA is AVA. Okay. This lemma shows that if L is a star-closed set of lines at 1690, then the vectors of length root 2 that span these lines form a root system. For example, the set Dn is a root system. The group generated by this is the reflection group, or the Weyl group, if you will. Yeah. The symmetry group of root system always contains multiplication by -1. Great. Whoa. Okay. It's called decomposable. It can be partitioned. Dn is indecomposable. Let L be a star, closed set of lines. Acts transitively on stuff. Okay. Where is the graph theory? We're getting back to it. It's right here. Right as you asked, Locke. Because it is Rn algebra. Now suppose X is a graph with minimal eigenvalue at least 2. So let's go. Lambda min of X is at least -2, sorry. Then the claim is that AX, the adjacency matrix plus 2I is the gram matrix. Wait, is this in one of the lemmas here that we just skipped? He did say this earlier. Right. I guess we kind of. Let's see. He says this at the beginning. Does he explain why it's true? Or do we have to think for ourselves? Here? Symmetric matrix with 0 diagonal. We take this, and so such that this is positive semi-definite. Okay. Is that true for us? Maybe. I don't know. Then this is true for some matrix, which is to say that this is the gram matrix. I see. Why is that true, though? Why is that true? So, what do we say? Am I an alien? Yes. This sounds like alien communication. It kind of is. It kind of is. All mathematicians are aliens. So, yeah, you heard it here first. Alien confirmed. Okay, we should probably try to understand this. So the claim is, we have a matrix. We have a matrix whose smallest eigenvalue is at least -2, and if we add twice the identity matrix to it, we should have a plus 2i should be positive semi-definite. Can we check that? I mean, can we check that just by taking the inner products of the columns? You like number theory videos and turtles? Well, I don't have any videos on turtles, but I do have, I think, some number theory videos. Well, in some of these live streams, we've definitely talked about a bunch of number theory. We've definitely talked about number theory in a lot of my live streams. And in some pre-recorded videos, I talk about number theory. But no turtle videos, unfortunately. If this is alien language, well, it's even more powerful aliens from further away. Yeah, we should be able to check this. We should be able to check this on inner products of the columns, right? Right. Hang on. Let's look up positive semi-definite matrices. Obsession with the distribution of prime numbers. That's maybe something we should get into at one point. Go in detail through. Let's go in detail. Let's see. Are we gonna trust AI on this one? I mean, this is fairly basic stuff, so I'm tempted to. Okay, it's enough to say that all the eigenvalues are greater than 0. So if we add 2i to the diagonal, if we add 2 to the diagonal, does that increase? Is there really like a linear relationship like this? Like if I take, like if lambda min is lambda min of, is there a general theorem that says lambda min of this is like at least lambda min of a plus n? Is this true? Positivity of matrices is just that of the bilinear form or quadratic form. Yeah. Right. So if we treated it as a collection of n vectors, I mean, it's a matrix with all, it's a symmetric matrix with all positive entries, right? I mean, we can view A as the matrix of all inner products, right? Well, I still don't get it. A was already then semi-definite, positive semi-definite matrix. Or positive is about the self inner products. Yeah. Symmetric, find the eigenvalues. Where is it? Here we go. This is what I want. Oh my god. The eigenvalue of that is roots of that, which should maybe be more... Yeah. Roots of that. You have some ideas for trying to explain the distribution of prime numbers, but you're very uneducated and lazy. Well, those two things really work against each other. If you're uneducated, but you're very motivated, then maybe you can learn something. If you're educated but lazy, well, that's probably worse. Because then, you're lazy, so you're not going to do anything with it. So realistically, probably it is unlikely those ideas are gonna work out, because very motivated and educated people have tried all sorts of all sorts of things already. So my recommendation to you would be to first try to get less lazy, and then once you're not as lazy, you'll have the motivation to try and get yourself educated. You saw a math professor once say good mathematicians are lazy. Okay, this is true, but don't misinterpret their meaning of it. So because I've said something like this as well before, but when I'm talking about mathematicians, and probably when this professor is talking about mathematicians being lazy, what is meant is not that they're not doing any work, right? Lazy in the sense that, they'll spend 10 hours a day writing or something, but what one is usually referring to is finding the slickest proof, right? Finding a proof where you're not just working as hard as possible, grinding through a bunch of cases, but you're finding some sort of conceptually very nice proof. So usually, if a math professor or researcher is talking about lazy, what they really mean is efficient. But they mean lazy in the sense of finding the quickest, nicest proof. They do not mean lazy as in does not work hard. So you do have to work hard. There's no mathematician on this planet no successful mathematician on this planet that has not worked hard. It simply doesn't happen. Okay. Symmetric matrix, real entries, blah blah blah, blah 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 blah. Hermitian matrix. Scalars, negative, indefinite, blah blah blah. Okay. I mean, I could try thinking about testing this against all vectors. I could. Hello, monist fix. Hello. There's got to be some slicker way to prove this, though, right? There's got to be some slicker way to prove this. Ramifications? Hey, stay away from my primes. Yeah, what am I... There's got to be some slicker way to do this. Gram matrix... Okay, there's gram matrix stuff here. That's what we want, but... There's got to be an easier way to do this. What's going on here? Well, we're trying to figure out... There's a claim in a book that basically says if we have a positive semi-definite matrix A, and if I add twice the identity matrix to it, then I should get, if I have a matrix A whose minimum eigenvalue is -2, and if I add twice the identity matrix to it, then its minimum eigenvalue should be at least 0. That's the point. Yeah, and maybe I just need to be doing this naively, right? So what, I take xa minus 2I, and I think about the determinant of this. I think about the roots of the determinant. And could I bound them somehow? Could I bound the roots of the determinant somehow? Yeah, it's tempting to somehow argue that this will contribute to a constant term. Right? Because if I took, like, somehow it would be like the original polynomial, the polynomial of the new thing, the constant term of the polynomial of the new thing would be like at least the constant term of the polynomial of the old thing, plus 2. Right? But then, no, what is that saying against the roots? What am I... gang, I'm losing my mind here, no? You are lazy in that way, though. You try to come up with new ideas to swiftly explain. Too bad you're lazy in the other way, too. Yeah. Yeah. Very random question, but do I know of any introductory textbooks for two-category theory? I don't know of any textbooks on it, but probably if you just Google notes on two categories, and I would look at a great example is the category of bimodules. That's a good one to go and understand. Go look up the category of bimodules. That's a very good example to understand. And lab, yeah, it will consume you. It's inevitable. Sorry, not sorry. I could test against the basis. Why would I do such a thing? Hey, Russ, how's it going? Two-category theory is basically just so an ordinary category, right? A classic example is the two-category of categories. So normally what you have in a category is like you have objects and you have morphisms between them, and then you also ask that you have some sort of composability of morphisms. But now in a two-category, not only can you have morphisms between objects, but you can have morphisms between morphisms. So there's sort of one level higher. And so classic examples include the two category of categories, because you have categories, you have functors between them, and then you have natural transformations between the functors. You might also consider naturally you'd go to a higher groupoid, but you could consider like the two groupoid of a topological space, where your objects are points in the topological space, your morphisms are paths between those points, and then your two morphisms are homotopies between those paths. Okay, but there's also something I'm being glib about here. There's a difference between a strict two-category and a non-strict two-category. I think the word bi-category comes up somewhere here. I always forget which one's which, but basically one of these you relax composition on the nose, and the other one you say composition up to a higher morphism or something. Roughly the idea. Yes, in short, category theory squared. That's true. Yeah, it is that simple. Well, I don't know what you were asking about, Locke, actually. But if you're asking about if it's that simple, yes, it is that simple. It's not that hard. That is beyond you for now. You haven't even taken linear algebra yet, but you do have to give a presentation on line integrals next week. That's cool. That's cool. Hey, once you take linear algebra, study some algebraic graph theory because it's really cool. If I factor out x minus 2, it's just the ordinary eigenvalue determinant, but shifted by 2. Oh, yeah, I see. Wait, hang on. Factor out x minus 2. Wait, how do I factor out x minus 2? What are you talking about? So it's xi minus a minus 2i. So it's... Oh, right. I see. Yeah, it's x minus 2. I see. Okay. Yes. Sweet. Great. Yes. And that will shift. Thank you, Locke. Coming in clutch in the chat. Yes. Okay, great. Wow. Fantastic. You think this defines a finite family of algebraic surfaces? Wait, what does? What? What are you talking about? Do you think we need to invent/discover new math to prove the Riemann hypothesis? I mean, probably. A lot of very smart people have been thinking for a long time about the methods we already have. Mind you, I guess like people have slowly pushed results closer and closer to... I'm very ignorant of this field, though, actually, so take what I say with a grain of salt. But, I mean, it could be possible that the existing math is strong enough. But, yeah, maybe it will take some new technology. Okay, bye, modules. Modules, what did we do to you? Huh? What? Oh, gotcha. What the hell is an intertwiner? It is, well, think about something that intertwines, right? Bloop, 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 bloop. Mixes something up. So normally, like an intertwining operation, say we have two representations of a group. We might call a morphism of two representations, we might call an intertwiner, right? Because it intertwines the group actions, because it says, it's a linear map where if you apply the first representation and then apply the linear map, you get the same result as if you had first applied the linear transformation and then the second action. So it twists them, it does this. This is what an intertwiner is. It's this. I hope that makes sense to you. Good teacher? Are you calling me a good teacher? Well, I hope so. I did watch the movie about Ramanujan. What do I think about him? I don't know. Cool guy. Did some cool stuff. Yeah. Weak 2 category, bigger than strict 2 category? Yeah, probably. I think I agree with that sentiment in general. You were asking intertwiner in the context of category of bimodules. I mean, same thing. Same thing, basically. Because, I mean, a module, I mean, this is pretty much like, you could just imagine, here I said representations of a group, but you could imagine that actually here G is an element of a ring, and pi and rho are just the actions, or just the action maps of the ring, and then T is now V and W are modules over some ring, and so this is just exactly also the definition of a ring homomorphism, or sorry, a module homomorphism. And so you can imagine, well, what's an intertwiner of bimodules? Well, it simply has to, I mean, you have both a left and right action, right? So an intertwiner of bimodules would have to simultaneously intertwine both the left and right bimodule actions. So, yeah. Yeah. My main field of math is in the local Langlands program. That's the area I work in. The determinant is a polynomial that defines an algebraic surface. One for each root. If A is spatially algebraic? I don't know what it means for a matrix to be spatially algebraic. With n roots, we have a finite number of algebraic surfaces. A is an n by n matrix. Can I translate that to English? Unfortunately not. I mean, the local Langlands program is very abstract. I mean, I can tell you vaguely something about studying symmetries and number theory, but I mean, at the end of the day, it's a set of very technical conjectures. There's some good, if you look at YouTube, there's a video from Quanta and some articles from Quanta, that give a sort of general public explanation of it. Probably will do a better job than I could on the spot right now. Vaguely, it's something about studying symmetries that connects analysis and number theory at a very high level. But anything more precise than that, I mean, I can't say it in English because it just doesn't have a translation into English. It's just a very mathematical kind of thing. Very pure math. Okay. I believe this now. So this is the Gram matrix of a set of vectors of length square root of 2. I don't know why it's the Gram matrix of a set of vectors of length square root of 2, though. This I do not understand. This does not make sense to me. Then we have an n polynomial with trivial finiteness for a number of corresponding algebraic surfaces. So I'm a real alien? Yeah, I wasn't lying to you. I'm a real alien. We have an n polynomial. I don't really know what you mean. I mean, the characteristic polynomial. Okay, so you're saying, yeah, I don't understand. I mean, yeah, a polynomial will cut out some curve in n-dimensional space. Spatially algebraic matrix is a matrix of functions. Okay. I suppose that's true. I suppose we could view the xi minus a is technically a matrix of functions. That's true. Right, I see. And you're saying as we vary x. No, if we look at the roots, but I mean the roots are just going to be the x that makes the determinant 0 is just some finite discrete number of points. I'm not sure I see how we get a surface out of this. You think we need to improve our communication with aliens? Us humans might benefit? Well, yeah, but I think the communications, well, like I said, there's already good articles out there. For Langlands. And the thing is, like, at some day, it's like you can ask someone, oh, what is the Iliad about? And someone can tell you about the Iliad, right? But if you want to go, read the Iliad in, like, the original ancient Greek text, you want to go read the original text, well, of course, you're not going to understand anything if you just go crack open the book, right? What you got to go do first is, like, learn, the very basics of the alphabet. And then you got to learn about, like, how to spell dog, cat, and bat in, like, ancient Greece. And then you got to learn about historical context, And there's a very clear path for how to go and do it. But, yeah, I mean, it's the same thing as just asking, oh, I want to be able to instantly read the Iliad in ancient Greek. Well, it's like, well, a polynomial on its own only defines a single submanifold in C2. Look up disk theorem. Min-max eigenvalues bound the average trace. Gorshkin There's Greshgorn cycles. Is that what you're talking about? I know something about Greshgorn cycles, but well, I'm about to wrap up stream actually, I think. So let me just conclude here, and we'll see. Maybe we'll come back to this. Come back to this in a second. Ground matrix. Okay. Okay, so maybe there's something I need to think about here. Why the length should be square root of 2. But whatever. And it says that they span a set of lines at 60 and 90 degrees. Okay, let's just believe it. So Lx will denote the star closure of this set of lines. Notice that the gram matrix determines the set of vectors up to orthogonal transformations of the underlying vector space. And therefore, Lx is uniquely determined up to orthogonal transformations. Mike lagging? Really? Huh. Well, I don't know what to do about that. Did that only start recently? Well, Leo, you said that an hour ago. So we'll see. Okay, so let's leave it off here. If X is a graph with minimum eigenvalue at least 2, then the star closed set of lines Lx is indecomposable if and only if X is connected. Ooh, that's a very cool result. Well, let's leave it there. Let's all meditate on that. Thanks again for joining me, and Q